rough. Okay, will you try this real quick? The test is tomorrow. While you're trying that, I'm going to pass back this test. Now, I want you to fix it tonight or over the weekend so I can make your scores better. Now, chopsticks. Half of you have still not turned it in. Half of you have still not turned this in. I think it's been well past reasonable time. If it's not to me by the first day back, then I'm going to put zeros in. Sound fun? Now, if you wonder what your score is, you can look online or subtract 5 for every single mark you see. Now, I want everyone to take this back. Look at the one you missed, fix it, and resubmit it. I'm hoping everyone can get 100% on this. I can't read it, so you got to retype it. Yes. I don't get it. Yeah. I don't. Oh, it's gross. Try that on the screen. Yep. This is an example question. Yeah. Yeah. Hey, Seth brought some extra pizza. If you want it, go over there and eat it. Okay, 1 second. Where'd he go? Oh, hello. Oh, thank you. More pictures, Alyssa. Hey, you guys should shush and try the problem. It's coming when I get to you, which is close. You're wasting your own time. Is Timmy here? You should add like why. I'm going to tell everyone that. Okay.
Wait, why do you have X's and I's?
I don't know. Okay, please listen. If you got one back and it says why, it means you said something true, but you didn't explain the reason. So like it'll say it gets smaller from left to right, and you say because it gets smaller from left to right. Well, I know that doesn't answer it. I need to know why. So it gets smaller from left to right because the Zeph increases, pulling the electrons closer to the nucleus. Yes.
So you just need to put Coulomb's law somewhere in there, and then Zeph.
That'll get you half of them, but don't just write because of Coulomb's law.
Like, yeah, and talk about why.
Yep. So if you got an X, it usually means you're wrong. If you got a Y, it means you stated something true, but not the whole way. Some of you like just missed the main key word. So don't, I don't know, like you missed that word.
That word?
Yeah.
That's all I need to split.
Sort of. Now there was some super wrong answers. And I'm not like, some of them just hurt my feelings. I don't know. But like they're exactly 100% wrong. So, anyway, watch the videos. Almost every one of them is answered in the lecture. If you have your score and you're like, oh, I got a 95, I feel great about that. Like, I'm okay with that, but I'd prefer to put a 1 and 2 zeros. So that's up to you. Anyway, okay. This is part of the review. This will be on the test exactly tomorrow. We're going to review a ton of stuff on here, and some of it will be on the test, like exactly. So let's take about 4 more minutes. Give us your best. Nobody wants more pizza? Okay. Is that one just looks and like okay, are you done then? You're silent and you're not done. Okay, I got to move on. Well, for your test score, bet that it would be better if I moved on. Okay, I did not pause so that it didn't mess up. I hate when it gets stuck in plus mode. Okay, draw the Lewis structure of C3H6. So we have 3 C's and we have 6 H's. If I remember right, we had 3. A double bond on the opposite side of the 3, correct? All right, and then I had an H, and an H up or down. It doesn't really matter. We okay with that? Does that match yours? Yeah, it's fine. Where the double bond is, which side, it doesn't matter. But 3 C's, or sorry, 3 H's on one C, 2 on one on the center one. All right, the geometry of each carbon atom. Whoops, that was supposed to not cross it out, but this was each of them. So this is 4. Tell your partner what 4 is. Tetrahedral. Good. This is 3. Tell your partner. Trigonal planar. And then this one is also 3. So that would be also trigonal planar. Easy enough. Balanced equation, C3H6 plus O2 goes to CO2 plus H2O. Correct? All right, it's a combustion reaction, so you should know that means it reacts with oxygen. It forms carbon dioxide and water. 2, 6, 6, 9. Is that right? 2966? Okay. All right. I won't do this whole problem just because it will take forever, but I'm going to have C3H6, which is this thing right here, right? So I broke 1, 2, 3, 4, 5, 6. I'm going to put a 2 right here, and then I'm going to put 6. Why did I put a 2 right there? Because the coefficient, and then I'm going to put a 6 C to H bonds. Why did I do that? All right, the 6 came from how many I broke. The 2 came from the coefficient. Plus, I have 1. I should just, which way do you want to do it? I'm going to do it this way. It'll be 2 times all of this in a second. So I have 1 C to C bond. Are we okay with that? Plus, whatever. You don't have to do that, I guess. 1 C double bond to C. Right here. Because I'm going to take all this stuff and multiply it by 2. Everything I've done right here is just for this part so far. And honestly, I would put another one right here. Plus, I have 9 O double bond to O, correct? Okay. And that would be, this right here takes care of that. And I would sum all of that up. That would take care of the bonds broken. Go ahead. Oh, okay. Then I'm going to subtract, and I won't have room here. So I'm just going to do it down here. I'm going to minus everything I write right here. I have 6. And then for each CO2, I have 2 C double bond to O's, correct? Plus, that takes care of that piece. 6. And for each water, I have 2 O to H bonds. Who's with me so far? It's tricky. It's just a lot of stuff, but it's doable. All right, then I would just plug in the numbers. Okay, and they'll be ugly. I'm just going to write over. So I have 413 for CH. C to C, I have 348. C double bond to C, I have 614. O2 is 495. C double bond to O, that's your 799. And your OH would be right here, 463. Then you get the answer raw. And it's like, that's the root of where all depression and anxiety started. It's been pushing the wrong button on a calculator when you know everything. You did it all right. And your fat finger hit plus instead of minus. Anyone do this? Should be a negative number. Is this 2023? Okay, never mind. 3,800. Someone double check it. I trust Isaac. On some tests, on one of these, the answer is negative 2023. I know it. Might be. We'll see.
Most of you guys graduated. I will graduate your after.
Did you guys match that number?
I got a percent, but
I didn't get there.
No one has this number to back it up. So we'll just trust Isaac. All in favor?
All in favor, I was correct.
You can trust someone with diabetes because they take life more serious,
thanks for that.
right?
I can back it up.
Okay, we have 2 people now with this number. So that makes me feel like it is likely correct. Okay, on the test, you have to do this. You have to. I skipped this part on accident. No, we did it, didn't we? On the test, it'll say the hybridization. So what's the hybridization of this carbon atom? Really, we do it for the central atom. Is all you have to do it. So let's look right here. How many electron domains did that central carbon atom have? It had 3. So sp2. The test will ask how many sigma and pi bonds. Sigma equals 1, 2, 3, 4, 5, 6, 7, 8. Correct? Pi equals 1. No, just the central one. Yep. Well, the geometry was for each, but on the test, it won't say each for these pieces. Okay. Thumbs up if you can do everything on that screen right there. Oh, that makes me sad. Well, the person I made eye contact with. Okay, that is on your test. 100%, that is on your test. All right, here we go. Give the name of the molecular geometry, the hybridization of each central atom, the bond angle, and the polarity of each of the following. I don't have the word bank up there. I do not plan to give you a word bank on the test. What? It would be a lot better. I said I would? I don't remember saying that. You can confirm? I'll pray about it. Okay, but for right now, try this. Instead of complaining, how about trying? There is a linear there pretty early on. Yeah. Trigonal bipyramidal. Trigonal bipyramidal. Because look, trigonal bipyramidal. I don't know. Everyone's whining that I said you'd have a test bank. I don't know. Like I said, I'll pray about it. I pray better when I'm caffeinated. Oh, you did? Whoa, here?
No, underneath the X. Over, wait, no, over, down, yeah.
What about it? What about it? I'm sorry. How many sides are there? So what's 4? Yes, but something changes here. Okay, 1 more minute. All right, we ready? So here we go. Let's start with just the molecular geometry. So we'll put this one in black ink. So what do we have here? Linear. Seesaw. What do we have here? Linear. What do we have here? Square pyramidal. Are you okay with that? Okay, next. Linear. Next. Trigonal planar. What do we have here? Bent. Here. Tetra. What do we have here? Square. What do we have here? Bent. More benter. Good. What do we have here? No, not benter. Octahedral. How about here? Trigonal bipyramidal. What do we have here? And T-shaped. Okay, who went 100%? You should have this memorized. All right, here we go. Hybridization we'll put in really small red. Here we go. Hybridization. SP. How do we answer that? It has 2 electron domains, right? Or like bonding, sorry, bonding domains. Bonding domains. Okay, what do we have here? We have 3 or 4 bonding domains this time, so what do we have here? What do we have here? No. You can't go more than 3, and S can't go more than 1. Okay. All right. How about here? SP. What do we have here? What do we think here? It's SP2. Now, this one, that's a good question. These are different. And let's just worry about that later. It's okay. I'll explain, but I don't want to waste time on it right now because it's not on the test. SP what? SP. What do we got here? SP. What do we have here? And did I do it wrong? And SP2, right? Okay, if we have time, I'll come back and talk. Next, we will have bond angles. 180. All right. 90s, 120s. I won't ask you bond angles besides the 4 basic ones. Okay. So we'll do these, but it'll be either 180, 120, 109.5, or a 90. You okay with that? Yeah, you don't have to have all of them memorized right now. And I don't even remember what this is. I mean, it's 90, but it would be affected by something else. That one's 90. These would be 120. All right, 180. We got between here, we got 90s, and here we would have 90. Trick question. Yep. All right, what do we have here? 180, 120. This one's bent, so it'd be less than 120. Is that the right less than sign? Sometimes I get them backwards in my head. Okay, 109.5. Now, technically, this would be a little bit less because the O, but we're not going to stress about that. All right, what do we have here? 90s. What do we have here? Less than 180. I don't remember what it is, but we don't have to have that one memorized. All right, all of these would be 90. These would be 90 and 120. This one would be, oh yeah, this is 109.5. You're right, 109.5. And then what do we have here? Well, not 190. That's not an option. No, they're 90s. They're 90s. Okay. Polarity. How we doing? Okay, what do we think here? Non-polar. What about this one? This one. This one. This one. This one. This one. This one. This one's sure. This one's barely polar. Okay, how do we know it? We're looking for when it's uniform, basically, or we're looking for unshared pairs that make it non-planar. I don't know if that helps, but that's what we're looking for. Now this one, let's just pretend this is Cl. Typically, tetrahedral is non-polar, but since it was O, it's slightly more polar than it should be. How about over here? Non-polar, polar, non-polar, non-polar. All those were the same. And then this one, polar, and this one, polar. So if you see electron pairs that are unshared, it's probably going to be polar. Now there's a few exceptions, like that linear one. Wherever, did everyone get the picture they wanted before I erase? Okay, I'm going to erase. Like, where am I looking? Where's the linear with all the extra ones? Oh, the first one, yeah. I'm not smart sometimes. This one has unshared pairs, but they themselves are all in the same plane, so they don't affect the polarity. But pretty much most of the time you would. Okay, I got to move on. All right. These come from the videos that Xander's watched, and just about no one else has watched any of them. Tons of your questions are cut and pasted from those videos for your information.
That's why we watched them.
All right. The energy required to separate ions in this, it has a name. What do we call when we separate ions in an ionic compound? The lattice energy. In the individual Mg and OH ions is right here. Okay, and then it shows you and it asks, why is strontium less? Explain why. So it takes 2,900 to pull apart MgOH2. It only takes 2,300 to pull apart SrOH2. According to Coulomb's law, why? Oh man, we did this already. I'm nervous. You two know?
Yeah.
Okay. Good thing we're reviewing, huh? Okay, I'm going to move on. Did anyone have an answer they felt very confident about? No. What? You thought it was great? All right, here we go. An answer that would get you for me to say why is if you said because Coulomb's law. And I'd be like, yeah, and give me more. Lattice energy is a function of Coulomb's law. F equals a constant that we don't really care about because it's constant. Q1, Q2 over R squared. Charge 1, charge 2. Has the charges of these things changed? No. So this must be testing your knowledge about the denominator. So what must be difference between them is that strontium is larger. It's a larger atom. It has more shells. Since strontium is bigger than magnesium, the distance between the two charges is larger. The force is smaller. Okay. It's all about Coulomb's law, but don't just write Coulomb's law. Fair enough. It says in terms of periodic properties, all that is just saying, hey, they're in the same family. Like, since they're in the same family, the only other thing that must change is the distance between them. So it's their size. All right. The potential energy diagram is given for C, triple bonded to O. We went over this before. Anytime you see one of these, you can tell I cut it from the AP videos. A student claims that the curve for CO would be less deep and this is the one that was weird, what? And it would be shifted to the right curve for C triple O. Do you agree? So what they're saying is it would look like this. Ignore that bump right there. Do you agree with this or not? Ready? Talk to your partner. 30 seconds. Ready, go. This is distance. Okay, we ready? Do we agree? First off, yes or no? Yes, we do. Triple bonds are stronger than single bonds, right? How come? They're sharing more electrons. So there's more attraction of the positive nuclei to the shared pairs of electrons. If you're sharing three pair or six, you have a stronger bond, which means it takes more energy to break it if we tried to reverse this process. Okay, so you would agree, all right, it is shifted, or it's less steep because it takes less energy, and it's shifted to the right because there's less attraction. Now they're both related to each other, but that would be the two things you would need to explain. This answer is answered on one of the videos, like really clear. This is cut straight from an AP video. Now, a lot of these will be on the test exactly. Some of them won't, but some of them will be exactly on the test. Okay, Draw a rough particulate model of an ionic solid of LIBr. Okay, this is an ionic substance, right? It tells you it's ionic. You were supposed to remember and be able to draw like an ionic chunk. Just what would it look like? Does this sound familiar? There's, yeah, one of them better be smaller. And they better be drawn a specific way. Give it a shot. Don't spend a ton of time on it. Just draw a bunch of circles and let's see what you get. You should put the plus and minus charges on them. Let's see what you drew. Yeah, that's not what I'm looking for. Did you use white ink?
Oh, and like the little, oh.
Something like that. Good job.
I should have said this. I do, but I don't. I had to find that knowledge. Oh, the weird
Oh, that.
Something like that.
Oh, didn't do that. I was just covered in the data that you don't know. Actually, forgot to record the class.
I don't know. It's definitely on the AP Classroom. It's called Ionic Structure or something like that. It's once you see this, it's very easy. It really is. Okay, are we ready? All right, good. So I'm looking for some bigger circles. I'm looking for some smaller circles. That wasn't very small. Let me change colors. So we'll like put them right here. Are we okay with that? Okay. Which one's bigger, bromine or lithium? Is it lithium? All right, so which one is? Bromine. So I would put a negative on the blues. And what would I do with the reds? Put a positive. That would absolutely meet the requirements for drawing an ionic solid. I wouldn't do one of each. That's fine. It needs to show two things. It needs to show that you know which is the larger atom. And it needs to show that you need to show them that you know the negatives are not next to each other and the positives are not next to each other. There's a grid-like lattice structure between them. So that's why you got to draw more than one of each, because that doesn't show the lattice. Okay, this one's supposed to be easy, I hope. All right, this one has a lot of words. You'd be like, I don't remember this at all. A particular interstitial, whatever, alloy is made of two elements, X and Y, where Y is the base metal. The alloy is made of 20% X, 80% Y. Draw a diagram of the solid alloy that contains 10 total atoms in a representative proportion of atom types. Something like that. That's close. Okay, try it. Does anyone have any idea what's going on? Good. That's part of it. Timmy says there's two black ones.
Yeah. I don't know where they go. I just know they're
No way.
Yeah. Nailed it. How did lunch go, Seth? How did the leader lunch go? Okay. All right, raise your hands if you know what you're doing. Raise your hands if you have no idea what you're doing.
What if I'm like an operative between space?
In Corbin's space. Okay. Oh, you're awkwardly in between everyone. All right, here we go. No. So I have 10 total atoms. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to have, it sort of matters. That's all you got to do. What's the uneven? Well, it only gave me 10. And I had to do 20, I had to do 2 black, 8 white. No. Inter means in between. Now, say it, Corbin. What was the other one you said? Substitutional. If this said substitutional instead of inter means like intermixed or in between. Substitutional, it would have been like same size but different element. Okay, so the key here, what do you have to illustrate? You have to illustrate different sizes, because it wouldn't be different sizes if it wasn't interstitial. I don't know if that's how you.
Interstitial is.
Okay, and then it asks you for the right ratio. And then the 80-20, the whatever. So you have to have them in between and different sizes. That's all they're looking for. Gabe. You would feel better about 11? Oh, you would feel less? No. I'm surprised they actually even did this. That's like so confusing. But yes. It doesn't have to be this way, but if it says the base one, usually that's the bigger one. All right. This one might take more time than I want, so I'm not going to go over it. Draw the Lewis structure of the formate ion. Remember, if it's an ion, it has to have a negative. Include all resonance structures if applicable. If there is one, then you draw the second one in a bracket and put a negative. What's the formal charge of the central carbon? Well, let's just do one. We are right with that. So we have H, C, O, and O, if I remember right. Formal charge. Do you remember how to do formal charge? It was valence minus a sign, right? You with me? No, oh gosh, why do I do this job? How many valence electrons does carbon have? 4. How many is it assigned? So it has 8 bonding, right? You take half of that number. So it's 4. So what's the formal charge on this carbon? 0. That's all you would have to do. In your drawing, indicate which bond length is the shortest. So I'm going to highlight blue, the bond length that is the shortest. You tell me where to put it. C double bond O. That would be my shortest. Why? Double bonds are shorter than single bonds because the positive nuclei are more attracted to multiple pairs. All right, compare the bond length of this bond to these bonds. And I don't need like an exact thing. I just need a rough, what would we say about the bond length? The carbon double bond oxygen bond, or sorry, yeah, I said it right, is shorter. Now, I won't ask this, but oh, I hate when I do that. Beware, AP could. It might ask you what the bond order is here and here. Anyone know that answer? Bond order. Bond order. Bond order, a single bond is 1, a double bond is 2, triple bond is 3. So we would just think, what? Oh, I thought you said it. You were close there. 1.5. Why is this going to be 1.5? Because it's a resonance, isn't it? HCOO. Okay. It is a resonance structure. So since it could be on this one or this one, the bond order here would be 1.5. I'm not going to ask you that, but try to remember that.
Wait, so if there wasn't a double bond, it'd just be flat.
Yep.
Wait, so what it says compare the bond angle to the superheat the O. You just want like it's smaller or it's bigger.
Yep. I don't need like this one is 108.6259 because I just need which one's bigger and smaller. Okay, what would the overall, without getting too technical, what is the bond angle here? 120. So not drawn correctly, right? Just like this. If we were doing the molecular structure, it would have been HCOO. But whatever. Okay, did I skip anything? I think we're good. I said I was going to spend that much time. This is the same exact question. Okay, compound J has 2 nitrogen atoms, X and Y. So here's X and Y. What's the hybridization of the nitrogen labeled Y? SP. Y. 2 bonding domains. A student claims that all the atoms in the molecule exist in a single plane. Do you agree with this student's claim? Why? Okay. So we have trigonal planar, bent. There we go. All right. And we have this one too, which makes it tetrahedral. So it's a no. All right. We did this one. It's similar to the last one. I want to hurry. Copper atoms and zinc atoms have the same atomic radius. Uh-oh. So it shouldn't be interstitial. It should be substitutional because we can substitute them in. So you should get rid of a few of them here. Which ones should you get rid of? A and C and really D, because they're not all the same. So you're only left with B. They're the same shape, I mean size roughly, and then they are different colors. Okay. A particle level diagram of a metallic element is shown above. This uses words I didn't use in the lecture, so let's make sure we get this one. Typically, metals are both malleable and ductile. The best explanation for these properties is that the electrons involved in bonding among metals are unequally shared and form non-directional bonds. I didn't use this term. I used delocalized. Okay, so non-directional means delocalized. Directional means they are localized. Okay. B, unequally shared and form highly directional bonds. So that one's gone, right? B is 100% wrong. Is there any truth in A? Which part is, there is a truth in A. All right, so that part was right, but they are not unequally shared. They're equally shared and form non-directional bonds or delocalized. That's why electrons can flow in electricity, and that's why the bonds don't break. They just bend because the electron's like, well, I can go around that corner. I don't really belong here anyway. Are we okay with that? Steel is an alloy containing iron and copper atoms. Sorry. Thank you. Carbon atoms. Which of the following diagrams best represents the particle structure of steel? You can't see them all. Let me shrink this. Oh, it's the whole thing. So you're in trouble. Okay, so do we think it's A? Why is A incorrect? All right, because the sizes are backwards, right? How about B? Probably. They're not going to be the same size. And we're not going to have big, little, big, little. So it had to be that one. Okay, I already talked about this one. It's lattice energy. It was Coulomb's law. Once again, this one though, it's changing the charge, right? NA's in family 1 are a +1, Mg's a +2. So then it would talk about the charge. Don't worry about solubility, electronegativity, or mass when you're talking lattice energy. All right. You might think mass and size are the same, but they're not. Like they're not at all. So like Parker Buchanan, last year, he and I weighed the same, but we're not the same size, right? I'm just fat and he's tall and skinny. Okay, here we go. Hard to read. The diagram above shows 2 resonant structures of the molecule C6H6. The phenomenon shown in the diagram best supports which of the following claims about the bonding in C6H6? It is a resonant structure. Okay, due to time, any guesses? It's actually A. Because remember, they're all 1.5s. Trick question, right? Because you're like, oh, I see it. Hey, listen, there's more. Watch the last end of this video as I go through so you can see them. Okay, we are out of time. We can discuss this one, I guess, but then I'll keep recording. I won't say much about them because I got class right now. So this is about formal charge. 2 CLs versus 2 BRs. What do we know about bromine versus chlorine? It's bigger. This would matter to this. Okay. I'm not going to say the answers, but these are a ton of questions, multiple choice that will be on there. You should watch the last part of this video and read them. They might be repeating, Brown. Are they repeating? Okay, they're not. Thank you.